Hi, I'm Dave Walsh. I'm with Vista Clara, and today we're in Larned, Kansas. And we're going to be demonstrating the CPMG pulse sequence. Brand new pulse sequence available on the GMR surface NMR instrument. Just going to start up a new sequence here. Select the CPMG sequence. We've already figured out what the NMR frequency is at this site. I'm going to select a shorter pulse length than the last one. A short pulse length will allow us to get a good resolution and a lot of echoes in the top 10 to 15 meters, which is what we're interested in at this particular site. Alright, so I'm going to go for 6 echoes. TR of 6. These, the rest of these are good. Alright, so let's just start it up. So here we go. We're starting the 6. You can see we're going to actually get 6 echoes out of this sequence. So the CPMG sequence, you'll hear it when it goes off in a minute here. It's going to send off a very fast sequence of 7 pulses. And so let's just hold off and wait for that to happen, and then I'll continue with my discussion here. And of course, a big truck's about to pass us right when we're listening for this. There you go. So you can probably hear that on the video. So it sounds a bit like a machine gun. Not quite as loud, but GMR in its normal data collection mode, it collects a complete set of pulse moments in one stack, and then it goes on to your next stack to get another complete set of pulse moments. And this is also convenient and useful because you have to stop your data collection early, for instance. You still have all of your pulse moments wherever you stop. You just may have fewer stacks of them. So GMR also starts at the highest pulse moment. Let's take a look at the bus voltage here before it starts its next run here. So if you keep an eye on the voltmeters there, they're starting up at about 150 in this case. And there it goes down the first set of CPMG pulses. And so you get the idea. Okay, so that's our first stack of data. So how long did that take? That probably took about 5 minutes. People are surprised when we tell them you can get a complete stack of CPMG data with 6 pulse moments, 20 pulse moments and 6 different echoes in 5 minutes. But hey, that's what we just did. Okay, we're transmitting on coil 4. Our reference is on channel 2. Let's see, let's do 100 Hertz bandwidth for spin echoes. That's a reasonable bandwidth. FID, we usually like to use 200 Hertz because you get faster decay usually, and you're looking for those short dead time signals. Alright, so this is called the QC program. Basically it takes the raw data, it filters it, removes noise, and stacks it over time. And you also can see the data in pretty clear resolution to see what's okay. So for example, here we've got some noise at the start of our data. We've got some big signal there. You can see the signal right down the middle of that big line there. You can tell it's an NMR signal because there's actually 2 interleaved records of pulse moments here. So you see it kind of peaks in the middle and then fades, and then it peaks again and fades. And that's what NMR signals do. They're nonlinear function of depth. And so it's a bit noisy, but not too bad. You can kind of see each echo. There's the first, second, third, fourth, fifth, sixth. Bit of noise on there. Let's see, this is a lot nicer. There's no excess noise on this data. Much nicer without that noise. Okay, so there's your sounding curve. That's for the spin echo. And so that's not the same as, well, it might be for the FID actually. Alright, so here's your, basically your, let's load this up. Alright, so here you've got pulse moments increasing. So these are large pulse moments and these are your small. And this is time. So you basically got your train of 6 echoes here as a function of pulse moments, starting at high pulse moment to low. So you see in here we've got a lot of refocusing water signals at these medium pulse moments. So that's from the sand aquifer here. It's in the 4 to 10 meter depth range. There's another aquifer below it, down to around 20 meters. So we're getting starting to get refocusing from that, higher pulse moments. The other thing is here you see the FID signal, the free induction decay signal. So you get that too with the CPMG sequence. You get the free induction decay, at least a short portion of it, and then you get 6, in this case 6 different echoes. So you can see actually each, as a function of pulse moment here, you've got your 6 echoes. So this being the first echo, the blue, then the green's the second, red's the third, this is the fourth. So as a function of pulse moment, you've basically got your initial or your echo signal amplitude. And what the inversion does is it takes this and it does a linear inversion to sort these echoes out into different depth ranges. Here's a rough inversion from 3 stacks here. This is just based on spin echoes again, the 6 spin echoes. And here's the water content. Now this is not showing all of the water content. It's only showing the water content that is refocusing in the spin echoes, which basically excludes anything with a T2 of less than 100 milliseconds. So this is just long. This is basically mobile water content here.